In this lesson, we will discuss an improvement on the Apriori algorithm using the vertical data format. We will go over the Equivalence Class Transformation ECLAT, where we look at how putting the data in a vertical format may offer opportunities to improve the performance of Apriori. As we studied earlier, Apriori uses horizontal data format where each transaction ID points to a list of items. ECLAT, on the other hand, uses the vertical data format where each item points to a list of transactions in which it appears. You can think about it as an inverted index in data structures, where the key is the item, the value is the transaction ID list. Now, suppose we set the minimum support to 2, we can easily identify the items that satisfy minimum support just by looking at the length of the transaction ID lists. So A, B, C, and E satisfy minimum support, and we prune D. Next, to find frequent to item sets, we can simply intersect the transaction ID sets for A and E, and we can see that it consists of 10 and 20. We continue this process to find the frequent 3 item sets and so on, just by looking at the intersection of the ID lists. The properties of a transaction ID lists that help the algorithm with pruning unnecessary steps are T of x equals to T of y, which means x and y always happen together. Transaction list of AC is equivalent to the transaction list of D. A transaction list of x is a subset of T of y. That means a transaction having x always has y. As you can see here, T A of C is a subset of T of C and E. Here's an example. We have 9 transactions in the horizontal data format. Minimum support equals to 2. We transform the dataset to the vertical data format, and at the first glance, it looks like all item sets meet the minimum support of 2. Next step, we go and compute the intersection between every 2 item sets, and we are able to prune 2 sets, I1, I4, I3, and I5. Next, we find the 3 item set, and we end up with I1, I2, I3, I1, I2, and I5. Finally, to save memory space, we can store the differences between transaction ID sets. For example, suppose we have TE equals to 10, 20, 30, TC equals 10 and 30. The intersection is 10 and 30, but we should be able to use the Diffset to find the support of C and E. The Diffset between C and E is 20. If I subtract the Diffset from the length of T of E, I end up with the support of C and E and save space from not storing the intersection. In summary, we discussed an a priori improvement through exploring the vertical data format.